Myself, I am Dr. K. Prasad, Department of Physics, Institute of Aeronautical Engineering. Today, continuation of research methodology and nanomaterial series. Today, I am going to discuss about nanomaterials numerical. First problem in nanomaterials numerical problem. First question is calculate the surface area to its volume ratio. So what they are asking to find out? Surface area to volume ratio. So surface area to volume ratio, what is the formula? 3 by R. And what they are given? Surface area to volume ratio of a spherical particle diameter. So they are given for diameter, not radius. What is the surface area to volume ratio formula is 3 by R. So we need to find out for radius, surface area to volume ratio. Within that, what parameter we need to find out? Radius. But what they are given? Diameter. So particle diameter, and what are the units they are given? Millimeter. So to calculate the problem point of view, how we should convert SI units? So millimeters into meters, 18 to 10 to the power of minus 3 meters. Then particle radius to diameter formula is 2r is equal to d. Radius is equal to d by 2. So diameter they are given. So diameter how much they give? 8 mm. 8 mm. 18 to 10 to the power of minus 3 meters divided by 2. So 2 4 ja. So we are getting for 4 into 10 to the power of minus 3 meters. Then we know the formula surface area to volume ratio is 3 by R, where R is the radius. So what is the radius we got here? Radius is 4 into 10 to the power of minus 3. Just here we need to substitute the values. 3 by 4 into 10 to the power of minus 3. So we got the resultant value is 0.75 into 10 to the power of minus 3 meters. Next problem. If the radius of sphere is made, means they are giving for radius is 1/3. How much radius is? Radius is equal to 1. Just you assume as 1. But what they are telling now? Radius is 1/3, means R by 3. How its surface area to volume ratio changes? Surface area to volume ratio, what is the formula we are having? 3 by R. So here, what is the radius they gave? Radius is equal to R by 3. So 3 by R by 3. So what we are getting? 3 3 ja 9. So denominator 3 will go for numerator 9 by R. So this one, how many times it is more than 3 into 3 by R. So surface area to volume ratio increases by 3 times. So that is the how its surface area to volume ratio changes. It is increases by 3 times. Next problem. If the dimension of a cube, means what they are telling, dimension of a cube is double. Cube lo unnatvanti, if the dimension of a cube is double, means a is equal to 2a. Cube is double. Then how its surface area to volume ratio? First, volume of the cube is a cube. What they are saying, if the dimension of cube a is equal to 2a. Then we are substituted volume of the cube is a cube. A cube, a is equal to 2a. So a is equal to 2a whole cube. Surface area of the cube is, what is the formula? 6a square. So what they are saying, a is equal to 2a, just we are substituted here. Then we are getting for 24a square for surface area of the cube, and volume of the cube is 2a cube. What is the formula? Surface area we know, volume we know. So surface area by volume we are dividing. So 24a square by 8a cube. So a square get cancelled. So here 8 3s are 24. So 3 by a remaining. So this surface area to volume ratio decreases by how many times? Means it is 2 times. That's all. So it is justified. Next problem. Calculate the average particle size using X-ray diffraction pattern having 0.1541 nanometers of X-ray wavelength. Means they are given the X-ray diffraction wavelength is 0.1541 nanometers first. So this wavelength they are given, and they are given for full width of maxima is 0.11 radian. Next point. Then diffraction angle is 45 they are given. What is the Scherer's formula we are having? D is the particle size, K is the constant. Constant is how much? Scherer constant is 1. Lambda is the wavelength. Wavelength they are given. So in terms of meters means 0.1541 nanometers. Nanometers means 1 nano is equal to 10 to the power of minus 9. So 10 to the power of 9. Full width of maxima is 0.011 radians. Angle of diffraction they are given is theta is equal to 45 degrees centigrade. Then what is the parameters? We know from the Scherer formula. What they are asking? Particle size. D is the average particle size, or we can also call as a average crystallite size. So Scherer formula D is equal to K lambda by beta cos theta. So here K is the Scherer constant. K is equal to Scherer constant. K is equal to 1. Next, lambda is the wavelength we know. Just we have substituted the value. Then they are given for full width of maxima. Beta they give. Cos angle of diffraction is how much? Theta is equal to 45. So cos 45 value. Then we are getting for resultant value is 1.98 into 10 to the power of minus 8 per meter. Next problem. A beam of X-rays is incident on a sodium chloride crystal with lattice spacing is the how much they are giving for lattice spacing is 0.282 nanometers. Means D they gave interplanar spacing or lattice spacing is same. So D is equal to 0.282 nanometers. What they are asking to calculate? Calculate the wavelength. Wavelength they are asking to calculate. Means we need to find out lambda is equal to how much. And what is the order they give? N is equal to 1. And Bragg's refraction takes place at a glancing angle theta is equal to 8 degrees 8 degrees per 35 Celsius they give. So theta we know. So what is the Bragg's law? Bragg's law is equal to 2d sin theta is equal to n lambda. So within this what they give? D interplanar spacing they give. they gave for theta, they gave for order is n is equal to 1. So which parameter we doesn't know? Only lambda. So what they are asking to find out? Lambda. So that one we are finding. So n is equal to 1. 1 into lambda is equal to 2 into d is equal to how much? 0.282 into 10 to the power of minus 9. Theta is equal to sine of 8 degrees 35 Celsius. Then resultantly we are getting the wavelength is how much we are getting? Lambda is equal to 8.419 into 10 to the power of minus 11 meters. Next problem. X-rays of wavelength is 1.5418 angstroms, means they gave for wavelength. So now they are not asking for wavelength. Now they gave for wavelength lambda is equal to 1.5418 angstroms. 1 angstrom is equal to 10 to the power of minus 10 meters they gave. Then diffraction. Planes. What is the plane they gave? Plane is equal to 111 plane. Then a crystal theta is equal to 30. And in the first order means n is equal to 1. Calculate the interatomic spacing. So what is the formula for X-ray diffraction wavelength? So Bragg's law is equal to 2d sine theta is equal to n lambda. So what they are asking to find out? They are asking to find out the d is equal to interatomic spacing or lattice spacing is how much? So here n lambda by 2 sine theta. N lambda by 2 sine theta. N is equal to 1. Here n is equal to 1. Wavelength is 1.5418 into 10 to the power of minus 10 meters by 2 into sine 30. Sine 30 how much? So this 1. So nothing but we are getting the value is 1.541 into 10 to the power of minus 10 meter is the interatomic spacing of this particular X-rays wavelength. Next problem. An X-ray beam of wavelength. So they gave for lambda is equal to 3 angstrom. That is here angstrom we are converted into meters. Means 1 angstrom is equal to 10 to the power of minus 10 meters. Next, they are given the planes is 100 plane. 100 plane they are given. Means that is nothing but H, K, L planes they are given. And what is the order? N is equal to 1. Order of diffraction is N is equal to 1. First order. Then glancing angle they are given. Glancing angle is equal to theta is equal to 40 degrees. So what they are asking to find out? Determine the spacing of a reflecting plane and also the volume of the unit cell. So they are asking for D, interplanar spacing, or lattice spacing they are asking. Then afterwards they are asking to calculate the volume of the cube is how much? Volume of the cube is a cube, always a cube. So now we are having the formula for Bragg's law. These X-rays diffraction. What is the Bragg's law? Bragg's law is equal to 2d sine theta is equal to n lambda. So what they are asking? D. So D is equal to n lambda by 2 sine theta. 2 sine theta. So just we have substituted the values. Then we are getting for resultant value is 2.33 into 10 to the power of minus 10 meters. So interplanar spacing, what we are doing, d is equal to a by square root of h square plus k square plus l square. H, K, L planes, what they are given? 1, 0, 0. So we are substituting 1 square plus 0 square plus 0 square. What is the interplanar spacing? A is equal to, we don't know, but we know the D. So D is equal to, here nothing but what they gave, A is equal to D square root of H square plus K square plus L square. So D is equal to 2.33 into 10 to the power of minus 10 square root of 1 square plus 0 square plus 0 square is equal to 2.33 into 10 to the power of minus 10 meters is the lattice value. A is equal to, A is equal to D square root of H square. So D we got. So D is equal to A by A is equal to 2.33 into 10 to the power of minus 10 meters. Just volume of the cube formula is equal to A cube. We know. So A is equal to 2.33 into 10 to the power of minus 10. So we are substituted cube means we are getting for 12.64 into 10 to the power of minus 30 meter is the value we got. We got interplanar spacing is 2.33 into 10 to the power of minus 10. Lattice constant value also same 2.33 into 10 to the power of minus 10. Then volume of the cube is a cube is the formula. Then we are getting 12.64 into 10 to the power of minus 30 meters. Next problem. In an X-ray diffraction experiment, means here also Bragg's law is applicable. The peak width at off maxima means full width of maxima is 0.6 degrees. They are saying, they are mentioning, and its corresponding angle theta is equal to 24 degrees. They are mentioning that value. Then calculate the crystallite size. So they are asking for D to find out. D is equal to K lambda by beta cos theta. K is the Scherrer constant is 1. Lambda is equal to how much value they give? Theta. Lambda is equal to 1.54 into 1 angstrom is equal to 10 to the power of minus 10 meters. Here it is given. Full width of maxima is 0.6 degrees. But we need to convert in SI units. So in radians, 0.01 radians. Theta, angle of diffraction. Theta is equal to 24 degrees. So sine cos 24 we need to find out. Then Scherrer constant is K is equal to 1. Just we are substituting K is equal to 1. Lambda is equal to 1.54 into 10 to the power of minus 10 meters divided by beta is equal to 0.01 radians into cos theta. Cos 24 degrees is equal to, we are getting the final value is 1.68 into 10 to the power of minus 8 meters. Next problem. Here, what is the angle? What they are asking, what is the angle? Means theta they are asking. What is the angle they are asking? Theta is equal to how much? What that theta at which third order reflection means n is equal to 3 they are giving. means order they are telling Bragg's reflection. So Bragg's law, n lambda is equal to 2d sin theta, n is equal to 3 they give. And wavelength, X-rays of wavelength is 0.79 angstrom. So we need to convert 0.79 into 1 angstrom is equal to 10 to the power of minus 10 meters. N is equal to 3 they give. And what they are given, interplanar spacing is 3.04 into 10 to the power of minus 8 centimeter. But what is our other units are there? All are in SI units. So we need to convert in meters. So 3.04 into 10 to the power of minus 10 meters. So Bragg's law is equal to theta is equal to this one. How we can write? What they are asking to find out? Theta, Bragg's angle. So theta is equal to n lambda by, so here this value n lambda by 2d. Then afterwards what sine function. So theta is equal to sine inverse, means nothing but they are asking theta is equal to sine inverse of n lambda by 2d. Just we have substituted the value. What are the values? They give sine inverse of n is equal to 3. Lambda wavelength is equal to 0.79 into 10 to the power of minus 10 to the power of minus 10 meters divided by, what is the value? 2 into d is the interatomic spacing. How much value? 3.04 into 10 to the power of minus 8 meters. 10 to the power of minus 10 meters. 10 get cancelled. So we are getting for sine value is 22.94 degrees. So the angle of diffraction for X-ray wavelength is theta is equal to 22.94 degrees. Next problem. Here also same problem, means they are asking for Bragg's law. Within that, which parameter they are asking? Here they are asking for order. So each and every problem, one time they are asked for order of refraction. One problem they are asking for interatomic spacing. In one problem they are asking for glancing angle. In one problem they are asking for wavelength. So within Bragg's law, what are the unknown parameter they are asking? We need to find out first. So within problem, first what they are given the data. Monochromatic X-rays of wavelength. For 10th problem, monochromatic X-rays of wavelength, lambda is equal to 1.5 angstroms. 1 angstrom is equal to 10 to the power of minus 10 meters. 10 to the power of minus 10 meters. Then they are given or incident on a crystal phase having interplanar spacing is 1.6 angstroms. So interatomic spacing also 1 angstrom. 1 angstrom is equal to 10 to the power of minus 10 meters. So 1.6 into 10 to the power of minus 10 meters. Finally, Bragg's law what they are given, and find the highest order for which Bragg's reflection maxima can be seen. So they are asking for n is equal to how much? N is equal to how much? What are the parameters they give? Means 2d sin theta, n lambda is equal to 2d sin theta. So n they are asking. So n is the unknown parameter. So how we can write? N is equal to 2d sin theta by 2d sin theta by lambda. So d is the interatomic spacing 1.62 into So 1.6 into 10 to the power of minus 10, and theta is equal to angle is they are given for theta is equal to 90, maximum angle meant 90 degrees. Then wavelength is 1.5 into 10 to the power of minus 10. Then we are substituting, we are getting value is 2.133, which is equal to order is maximum 2. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.